Three neighbors share a single wood-burning stove, and a question none of them can agree on. Emma brings 3 logs. Lucas brings 5. Sophia brings none at all, but she does pay $8 for the fuel she used. The $8 has to be split between Emma and Lucas. Who gets how much? Pause and try it. Almost everyone, immediately without hesitation, $4 each. They are wrong. The correct split is $1 and $7. Here is why. The most common answer starts with the total. $8, 2 people receiving it. 8 divided by 2 is 4, $4 each. That feels completely fair. Equal shares, clean, simple. But notice what this calculation never asked. It never asked how many logs Emma brought or how many Lucas brought. It treated them as identical. They are not identical. Emma brought 3 logs. Lucas brought 5. Pretending they made equal contributions is the error. Wrong. Some people catch that mistake and try harder. They say, use the ratio. Emma brought 3 out of 8 logs, so she gets 3/8 of $8. $3. Lucas brought 5, so he gets 5. 3 plus 5. This seems more rigorous. It is still wrong. Here is the flaw. This method pays Emma and Lucas for every single log they brought, including the logs that they themselves burned. Emma burned some of those 3 logs cooking her own meals. Lucas burned some of his 5 cooking his. Why should Sophia pay them back for fuel that warmed their own food? Both wrong answers ask the same question in different ways. Who contributed more logs? That is the wrong question. The right question is this: who gave away more fuel than they actually used? Because Sophia is only paying for the logs that kept her warm, the excess that Emma and Lucas gave up over and above their own consumption. That is what she owes. And that is what we are about to calculate. Let us put the numbers on screen. Emma brought 3 logs. Lucas brought 5. Sophia brought 0. Total logs available, 8. All 3 people used the stove equally. Same number of meals, same heat, same consumption. 8 logs shared equally among 3 people. Each person consumed 8/3 of a log, roughly 2 2/3. That is the fair share, the amount each person owes for the fuel they used. We draw that line on the chart. Everyone is accountable for the same amount. The question is simply, who already covered their share and by how much? Now we subtract. Emma brought 3 logs. She consumed 8/3. 3 minus 8/3. Convert 3 to 9/3. 9/3 minus 8/3 equals 1/3. That is Emma's net contribution, the fuel she gave to the stove above and beyond her own usage. Lucas brought 5 logs. 5 is 15/3. 15/3 minus 8/3 equals 7/3. Lucas's net contribution, 7/3 of a log. Notice that Sophia's bar stays at 0. She consumed fuel but contributed none, which is exactly why she owes. The ratio of net contributions, 1/3 to 7/3. The ratio simplifies to 1 to 7. That is the ratio in which Emma and Lucas gave away their fuel. So that is the ratio in which they receive payment for it. $8 in the ratio 1 to 7. 1 part goes to Emma, $1. 7 parts go to Lucas, $7. 1 plus 7 equals 8. The accounts balance. This is the only fair split. Look at the method column. 4 plus 4. Equal division. Ignores who brought more. 3 plus 5. Gross proportional. Rewards total input, including fuel each person burned themselves. Both answers ask the wrong question. 1 plus 7. Net contribution. The only method that measures what each person actually gave away to the others. That is the answer. That is the principle. What makes this principle powerful is that it shows up everywhere people share costs or benefits unevenly. We will solve it in business, where partners invest different amounts of capital, and in travel, where friends pay different portions of a shared bill. The logic is identical each time. The principle in one sentence. Payment is proportional to what you contributed minus what you consumed. Net contribution, not gross input. Emma, 3 logs contributed, 8/3 consumed. Net, 1/3. That earns her $1. Lucas, 5 logs contributed, 8/3 consumed. Net, 7/3. That earns him $7. Equal feels fair. Net contribution is fair. And now, 2 more examples to prove it. 3 business partners start a company. Alex puts in $3,000. Ben puts in $5,000. Clara puts in $2,000. Total capital, $10,000. At the end of the year, they have made a profit of $2,000. The question, how do they split it? The tempting answer, 2,000 divided by 3, roughly $667 each. Fair, right? Equal partners, equal profit. But they are not equal partners. Alex invested 40% less than Ben. Clara invested 60% less than Ben. Treating them as identical erases the entire meaning of investment. The correct method: reduce the investments to their simplest ratio: 3,000, 5,000, 2,000. Divide everything by 1,000. Ratio 3 to 5 to 2. Their profit shares should mirror their ownership stakes. Alex owns 3/10 of the business. 3/10 of $2,000 is $600. Ben owns 5/10, half the company. 5/10 of 2,000 is 1,000. Clara owns 2/10. 2/10 of 2,000 is 400. 600, 1,000, 400. Add them. 600 plus 1,000 plus 400 equals 2,000. Every dollar accounted for. The profit chart mirrors the capital chart exactly. The taller the bar going in, the taller the bar coming out. That is not coincidence, that is the principle. Profit is proportional to capital invested. Contribution in, benefit out in the same ratio. Identical structure to the log problem, just a different context. 3 friends go on a 2-week trip. All expenses are shared, but throughout the trip, not everyone pays at the time. Maya books the hotel and pays $120 out of her own pocket. Kai picks up the grocery run, $60. Sam pays nothing, $0. Total expenses, 120 plus 60 plus 0, $180. 3 people. Each person's fair share, 180 divided by 3 is $60. Everyone owes $60 of the trip's total cost. Now we apply the same logic. Net balance equals what you actually paid minus what you owe. Maya paid 120, owes 60, net positive 60. She overpaid by $60, so the group owes her 60. Kai paid 60, owes 60, net 0. Perfectly balanced, no debt in either direction. Sam paid nothing, owes 60, net negative 60. He underpaid by $60. 3 lines, Maya plus 60, Kai 0, Sam minus 60. The calculation takes 3 seconds once you know the framework. The settlement is now obvious. Sam owes $60. Maya is owed $60. Sam pays Maya $60 directly. One transaction, accounts cleared. Kai's account was already at 0. He paid exactly his fair share, so he neither receives nor pays anything. A single payment between 2 people settles a trip shared by 3. Net contribution determines the settlement, exactly as in the log problem, exactly as in the business partnership. The context changes. Fuel, capital, shared expenses, but the arithmetic is the same every time. Subtract what you consumed. Settle the difference. How would you have split it before watching? If you enjoyed unraveling this mathematical mystery with us, hit the like button and subscribe for more deep dives into math and science. Let us know in the comments what other puzzles we should explore next. Thanks for watching.